All right, not too bad, I might say. So we'll start reading this while it completes the responses. It's the advantages of database systems. A database system is a computerized system that allows users to store, manage. Let me turn on this and retrieve data efficiently. It overcomes the problems of traditional file-based systems. The key advantages are reduced data redundancy. In file-based system, the same data was stored in multiple files, leading to duplication. In a database system, data is stored in a centralized location, so the same data is not repeated unnecessarily. This saves storage space, data consistency, since data is stored in one place and redundancy is minimized. Any update to data reflects everywhere. This ensures that all the users see the same up-to-date information, eliminating inconsistency. Data sharing. Multiple users and applications can access the same database simultaneously. For example, in a university database, both the accounts department and the academic department can access student records at the same time. Data integrity constraints can be applied to ensure that data entered into the database is valid and accurate. For example, a student says cannot be negative number. The DBMS enforces these words automatically. Data security. A DBMS provides mechanisms to control who can access what data. Different users can be given privileges, read, write, delete, protecting sensitive information from unauthorized access. Data independence. The database separates the physical storage of data from the logical view. Changes to how data is stored do not affect the application programs and vice versa. This is called independence. Backup and recovery. And AVMS provides tools to automatically backup data and recover it in case of system failures, hardware crashes, or accidental deletions. Concurrent access control. Multiple users can access and modify data at the same time without conflict. The DBMS uses concurrency control mechanisms to ensure that simultaneous operations do not corrupt data. Reduced application development time, since the DBMS handles many tasks. Security backup query processing. Developers can focus on business logic, reducing the time and cost of to develop applications. Standardized data access. All data access happens through a standard query language SQL, making it easier to manage and query data uniformly. Compare the entity and entity set. A single distinguishable real-world object is called entity. A collection of entities of same type is called entity set. It is an individual instance, whereas entity set is a group or collection. Example: a particular student Ravi with roll number 101. All students in the university. Represented as row or record, represented as a rectangle in here diagram. Has specific values for attributes. Shares the same set of attributes. Each entity is unique. An entity set groups similar entities together. An entity is like one specific person. An entity set is like entire students table containing all students. An entity set is sometimes called a class, and each entity is an object or instance of the class. What is a relational database? Is it still writing? See, okay. A relational database is a type of database that organizes data into tables, also called relations. These tables consist of rows called tuples and columns called attributes. The data in different tables can be linked to each other through keys, common columns. Key characteristic. Data is stored in structured or tabular format. Each table represents one entity type. Example: student, course. Tables are related to each other using primary key and foreign keys. Queries are written using SQL structured query language. Yeah, these two tables can be related through a common key like roll number or course ID in a third table showing which student is enrolled in which course. Popular relational database management systems are DBMS, MySQL, Oracle, PostgreSQL, Microsoft SQL Server. Define schema. A schema is a logical structure or blueprint of a database. It defines how data is organized, what tables exist, what columns each table has, what data types the columns hold, and what relations exist between tables. Think of a schema as a skeleton or design of the database. It does not contain the actual data, just the structure. Types of schema, three-level architecture, physical schema, internal schema describes how data is physically stored on disk, file structure, indexes, storage blocks. Logical schema, conceptual level describes what data is stored and the relationships between them. This is schema most developers work with. View schema, external level, describes how individual users or groups of users see the data. Customized views for different users. This turns a structure, table name, column name, and the data types without any actual data values. What is a relational table? A relational table, also called a relation, is the fundamental unit of data storage in a relational database. It is a two-dimensional structure made of rows and columns. Structure of a relational table: columns, attributes. Each column represents a property or characteristic of the entity. Each column has a name and a data type. Rows, tuples. Each row represents a single record or instance of the entity. Example: employee table. Properties of relational table. Each cell contains a single atomic indivisible value. Just a second, wait, I will come back. Each cell contains a single atomic or indivisible value. Each column has a unique name. All the values in a column are of the same data type. Each row is unique, no duplicate. The order of rows and columns does not matter. Every table must have a primary key that uniquely identifies each row. Define key. A key in a database is an attribute or a set of attributes that is used to uniquely identify a row tuple in a table. Keys are fundamental for maintaining data integrity and establishing relationship between tables. Types of keys: superkey. Any attribute or combination of attributes that can uniquely identify a row. Candidate key: the minimal superkey. A superkey with no redundant attributes. A table can have multiple candidate keys. Example: roll number is a candidate key. Roll number name is not because name is extra. Primary key: one candidate key chosen by the designer to uniquely identify rows. It cannot contain null values. Example: roll number is the primary key of the student table. Foreign key: an attribute in one table that refers to the primary key of another table. It establishes a link between two tables. Example: department ID is the student table. In the student table, referring to department ID in the department table. Composite key: a primary key made up of more than one attribute. Example: student ID, course ID together identify enrollment in an enrollment table. Alternate key: candidate keys that are not chosen as a primary key. What are the uses of normalization? Normalization is the process of organizing database to reduce data redundancy, duplicate data, and improve data integrity, accuracy, and consistency of data. It involves decomposing large, poorly structured tables into smaller, well-structured ones. Why is normalization needed? Without normalization, a database can suffer from anomalies. Insertion anomaly: you cannot insert data about one entity without inserting data about another. Example: you cannot add a new department unless you have a student in it. Deletion anomaly: deleting one record may accidentally destroy other important information. Example: deleting the last student of a department also deletes the department's details. Update anomaly. Okay, I'm supposed to turn on the charging. Update anomaly. Updating data in one place but not all places leads to inconsistency. Example: if a teacher's phone number is stored in 50 student records and the number changes, all 50 rows must be updated. One and the first normal form. All columns must have atomic values, no repeating groups. Second normal form must be one and a half, no partial dependencies. Three and a third normal form must be two and a half, no transitive dependencies. BGNF. Boys got normal form, stronger version of 3NF. Yeah, this is actually very long to be honest. But still, it is going on smoothly, so we should be reading it. BZN, a stronger version of 3NF, 4NF, and 5NF handle multi-valued and joint dependencies. Benefits of normalization eliminates redundant data, ensures data consistency, makes database design more efficient, simplifies maintenance and updates. What is the use of join? A join in a SQL operation is used to combine rows of two or more tables based on a related column, usually a common key between them. Joins are essential because in a relational database, related data is split across multiple tables for normalization purpose, and joins are used to retrieve it together. Why joins are needed? Suppose you have a student table and a department table. To find each student's department name, you need to join these two tables on their common column department ID. Types of join. Inner join returns only the rows where there is a match in both tables. Left join returns all rows from the left table and matching rows from the right table. Unmatched rows from the right shown none. Returns all rows from the right table and matched rows from the left. Full outer join returns all rows from both tables. Cross join returns the Cartesian product. Every combination of rows. Self join. A table is joined with itself. Select student dot name department name from student. Inner join department dot student dot department ID is equal to department dot department ID. So you in the output you will have name and department name, and the condition you are using is the similarity in the department ID. List the acid properties. Acid stands for the four essential properties that guarantee database transactions are processed reliably. They ensure that even in the event of errors or failure, the database remains correct and consistent. Atomicity. A transaction is treated as a single unit. It either completely executes or does not execute at all. There is no partial execution. Example, in a bank transfer of 5,000 from account A to account B, either both the debit from A to credit and credit to B happen or none happens. Consistency. A transaction must bring the database from one valid state to another valid state. All integrity constraints must be satisfied before and after the transaction. Example, after a bank transfer, the total money across both accounts must remain the same. Isolation. Multiple transactions happening concurrently must not interfere with each other. Each transaction must execute as if it is the only transaction running. Example, if two users are booking the last seat on a flight at the same time, only one should succeed without the other seeing the intermediate state. Durability. Once a transaction is completed successfully, its effects are permanently saved in the database even if there is a system crash or power failure immediately after. Example, after confirming an online payment, even if server crashes, the payment record should not be lost. Why do we use indexing techniques? Indexing is a database technique used to speed up the retrieval of data from the database. Without an index, the database must scan every row in the table to find matching records called full table scan, which is very slow for large databases. An index is like a separate data structure, like a books index that stores the value of a specific column along with a pointer to the actual row location on disk. Why indexing is used? Faster query execution. Instead of scanning all rows, the database uses the index to directly jump to the relevant rows. Efficient sorting and searching. Indexes help in order by, group by, and where clause operations. Improved performance. Significantly reduces disk I/O or read operations for large tables. Quick data location. Indexes store the location physical address of data so retrieval is fast. Example, without index searching for a student with roll number 5000 in a table of 1 million rows must check 1 million rows. Example with index. The index directly points to dislocation of roll number 5000 retrieved in milliseconds. Common indexing techniques. B-tree index used for range queries. Hash index used for equality queries. Dense or space index. Index entry for every record versus only some records. Clustered or non-clustered index when data rows are physically sorted by the index or not. Okay, further. Not too bad, not too bad. Right. Explain three-tier schema architecture with a namespace. The three-tier schema architecture, also called ANSI or Spark architecture, is a framework that separates a database system into three distinct levels of abstraction. The goal is to achieve data independence. Change at one level do not affect the other level. The three levels. Level 1 external level or view level. What users use. This is the topmost level and is closest to the end users. It depends on individual users or groups of users perceive and interact with the data. Different users can have different views, customized portions of the same database. A student might only see their own marks. A faculty might see all student marks. An admin might see everything. Each such personalized representation is called an external schema or user view. User at this level do not need to know how data is stored or organized internally. Level 2 conceptual schema logical level. What data exists? This is the middle level. It describes the entire logical structure of the database. What data is stored, what relationships or what constraints apply. This level is maintained by the database administrator. It contains the definitions of all tables, attributes, and the data types. It does not deal with physical storage. It hides the complexity of physical storage from users. Example, the conceptual schema might define. Okay, level 3, internal level, physical level, how data is stored. Okay, this is what data, this is how data is stored, what users see. This is the lowest level, dealing with the actual physical storage of the data on disk. It defines how data is stored, file format, record lengths, which indexes are used, how data is compressed or encrypted, physical access paths. This level is managed by data, DBMS, and invisible to users. Okay, this is not too bad. Yeah, is it? Nope. I think taking a screenshot would be a better option. Okay, still it is smaller. Okay, I don't wanna check it now. Data independence, the main benefit. Physical data independence. Changes to internal level. Example, changing file structure, adding an index do not affect the conceptual or external levels. Logical data independence. Okay. Changing the conceptual level. Example, adding a new table or attribute do not affect the external use. Applications still work without modification. Illustrate the database system structure. The database system structure describes how the components and modules that make up a complete DBMS and how they interact with each other. Components of a database system structure. Users or application programs. There are different types of users who interact with the database. Naive users. Yeah, 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 yeah. Okay, this is also a good diagram, which is easier than what was given to us. Okay, okay, okay. Okay, not too bad, honestly. Yeah, we are here, right? The database system structure describes all the components and modules that make up a complete DBMS and how they interact with each other. Components of a database system structure, users or application programs. There are different types of users who interact with the database. Naive users interact through pre-built application interfaces. Example, bank tellers using ATM software. Application programs, right? Programs like Java, Python using embedded SQL. Sophisticated users write SQL queries directly. Analyst DBS, database administrator manages and maintains the database. Okay. Query processor handles the user queries and translates them into executable instructions. DDL interpreter processes data definition language commands, create, alter, drop, and stores definition in the data dictionary. DML compiler translates DML queries, select, insert, update, delete into low-level instructions. Query optimizer finds the most efficient way to execute a query. Query evaluation engine executes the low-level instructions. Storage manager manages data storage and retrieval from disk. Authorization and integrity manager checks the access permissions and integrity constraints. Transaction manager ensures asset properties, manages concurrent transactions. File manager manages allocation of storage space and disk file structures. Buffer manager manages data transfer between disk and main memory. Mhm. Okay, 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 okay. What is this? Authorization, transaction, file manager, buffer manager, data dictionary, some metadata, data about data. It contains table definitions, attribute names and types, constraints and types, user privileges and access rights, index information. System categorization, physical database, disk storage, actual data stored in disk files, actual tables and records, index files, indexes for fast access, log files, records of all transactions used for recovery, statistical data used by the query optimizer. Elaborate the entity sets with an example. What is an entity? An entity is any real world object or thing that has an independent existence about which we want to store data in a database. Example of entities: a specific student Ravi, roll number 101, a specific car Toyota Innova, a particular bank account. What is an entity set? An entity set is a collection of all entities that share the same type of characteristic. All entities in an entity set have the same attributes, though with different values. Examples of entity set: student, all students in a university; employee, all employees in a company; product, all products in a store. Types of okay. Wait a second, I need to check if the quota for the Gemini has been stored or not. Yeah, it is just the boat. Mm. does not have a primary key of its own. Its existence depends on a strong entity set called the owner entity. It uses a partial key discriminator combined with the owner's key to uniquely identify itself. Mhm. Strong entity set has a primary key. Okay. Its existence depends upon the strong entity set. It uses a partial key or combined with owner's key actually. Example, dependent family members of an employee depends on employee entity. A dependent named Anita cannot be uniquely identified without knowing which employee she belongs to. Okay, because Anita cannot be uniquely identified because Anita does not have any primary key relating to her. Only primary key or employee ID exists for an employee, and through that employee, you can get the details of the family members of the employee. Makes sense. Attributes of an entity set. Attributes are the properties that describe an entity set. Simple attribute cannot be divided further. Example, age, roll number. Composite attribute can be divided into subparts. Example, name, first name, middle name, last name. Single valued attribute has one value per entity. Example, roll number. Multi-valued attribute can have multiple values. Example, phone numbers. A person can have more than one phone number represented with double ellipse in your diagram. Derived attribute calculated from other attributes. Example, age can be derived from date of birth represented with dashed ellipse. Null attribute attribute with no value or unknown value. Okay. 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 Example, complete year representation. What are constraints? Exam explain the mapping cardinalities. Constraints are rules or restrictions applied to the data in a database to ensure data integrity, that the data is stored is accurate, valid, and consistent. Types of constraints. Domain constraint. Every attribute value must come from the defined domain, data type, and valid range of that attribute. Example, age must be an integer between 0 and 150. Key constraint uniqueness. The primary key of a table must be unique for every row and cannot be null. Okay. Entity integrity constraint. The primary key cannot be in null value. Every entity must be uniquely identifiable. A referential integrity constraint. A foreign key value must either match an existing primary key value in the reference table or be null. Department ID in student table must match the department table. Not null constraint. A column cannot have a null or an empty value. Check constraint ensures that all values in a column satisfy a specific condition. Default constraint provides the default value when no value is inserted. Mapping cardinalities. Cardinality ratios describes the number of entities in one entity set that can be associated with entities in another entity set through relationship. There are four types of mapping cardinalities. Okay, one entity certain associated with at most one entity certain employee department. One entity department employee department. Many to many. Many entities in set A can be associated with one entity in set B. Many students can enroll in one course. Many, okay. One employee, one department. One department, many employees. One student, okay. Many students, one course. Many employees, one job, or maybe. Many students enroll in in one course from the student's perspective. Give me examples of four types of mapping cardinalities. Give examples of four types of mapping cardinalities. A person has one passport and each passport is assigned to one person. A customer can place many orders, but each order is placed by only one customer. A student can take only one course, but one course can be taken by many students. Each customer may place an order for many products, and each product might be ordered by many customers. Okay, person passport. Okay, this is honestly better, right? A customer can place many orders, but each order is placed by only one customer. A student can take only one course, or one course is. Explain the selection and projection with an example. Okay, what is the time? 37 minutes. I see. 37 minutes. I think I need to take a break in like 13 minutes. And then I will come back. Explain the selection. Selection and projection are two fundamental operations of relational algebra. The theoretical foundation for data. The theoretical foundation for database query. Oh God. Like SQL selection. The selection operation is used to filter rows or tuples from a relation that satisfy a given condition predicate. It returns a horizontal subset of relation. Horizontal subset of a relation. Okay, it selects specific rows. Sigma condition of relation. The number of columns remain the same. The condition can use comparison of select department IT from employee. So it selects this employee 1 and employee 3. Okay, find employee with salary greater than 55,000. So it selects E02 and E03. Okay. Projection. The projection operation is used to select specific columns attributes from a relation. It returns a vertical subset of relation keeping only required attributes. Project attribute list relation. Okay. Okay. So display only the name and salary of all employees. Okay, so it removes this employee ID and department. Combined example, selection and projection. Display the name and salary. Select department ID is equal to IT from employee. Select. Okay, so this is a select command and this is the project command. No, wait. Projection. Specific columns. But this is like, okay. If you really think about it, the select command is doing projection. The select command of SQL is actually doing the job of projection because it is selecting specific columns from a database. Right? Projection specific column. Select this projection because it reduces the relation to only these two attributes. In relation algebra, selection is about filtering rows that is handled by where clause. I did not used to get the difference between that because the name is kind of, it is like misleading. The select command is actually doing the job of projection. That is a great realization. Okay, what is the use of join? Explain the different joins. A join is a relational algebra and SQL operation that combines tuples from two or more relations based on a common attribute, usually a shared key. Since relational databases store data in separate normalized tables, joins are needed to bring related data together for querying. Come on, 42 minutes. Data normalization splits information across tables. Joins allow querying data from multiple tables if it were a single table, essential for meaningful data retrieval in real applications. Types of join. Cross join combines every row from the first table with every row from the second table. No condition is applied. If table A has m rows and table B has n rows, the result is m times n rows. So, okay. This is rarely used in practice and it produces massive result sets. Inner join, natural or equi-join, returns only rows where there is matching value in both tables based on the join condition. Equi-join uses equality as the join condition. Select star from student, inner join, department. Automatically joins in columns with the same name in both tables and removes duplicate columns. Left outer join returns all rows on the left table and the matching rows on the right side. If there is no match, the columns on the right table are filled with null. Okay, there is no corresponding department name for this department O3, so it will be done with null because there is no corresponding department name for department ID D03. Okay, okay, okay. Self-join. A table is joined with itself useful when the table has a hierarchical relationship with itself. Okay. I'm feeling sleepy now. Find article such that predicate is true. Okay. Okay, okay, okay. Okay, you just can write all of these things, right? DML operations, data manipulation language. Right, it is actually DQL, right? Is select DML operation. What are some examples of real operations? Okay. Insert into the updates at column that salary where delete from delete from employee uh, drop table. So you just need to write a running notes of these things, like listing down the important points instead of writing everything out. Okay, 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 not required all of this. Create databases, okay, create table, primary key, foreign key, plan the database, okay, create the parent tables first, okay, 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 create table, okay, okay, right. No, you don't need to write all of these things. Enrollment table, okay, insert some values, okay, not required at all. If you want to retrieve data, you can join. Like you can use the single table schema like student and course and use the same example for all of the answers. A nested query, nested query, single row subquery, multi row subquery, correlated subquery. The inner query refers to a column on the outer query. It is executed once for each row of the outer query. What is correlated subquery? What is correlated subquery? It is actually heating a lot. Let's see. Yeah, as you can see, the temperature. There is a temperature. 6 hours of uptime. Why is it having 6 hours of uptime? IPv4. NPU is having the 7.6 GB of share. Okay, not too bad. Yeah, that checks out. Correlated subqueries are powerful SQL features that allows a subquery to reference columns from the outer query. This makes subquery dynamic and is executed one for each row processed by outer query. When working with linked servers, correlated subquery can be particularly useful for querying. Oh, what is a correlated and non-correlated subquery? I did not really understood that. A subquery that runs independently of the outer query. It is executed once and result is passed to outer query. Okay, that makes sense. The inner query does not depend on the values of the outer query. What is it? It is non-correlated subquery. But what is written here? Okay, there is a where clause, right? Yeah. S2 dot department ID is equals to S1 dot department ID is inner query refers to outer department's current row. Find students whose marks are the above average marks of their own department. Select S1 dot name, S1 dot marks, S1 dot department ID from student 1 where S1 dot marks is equal to select S1 from student S2 where S2. Okay, okay, that makes sense honestly. Okay, okay, okay. Like a fixed benchmark, this where comparison is actually making sure it gets executed for each row, so it became a correlated subquery. Okay, 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 okay. How do you use group by class? Group by class is 53 minutes. I will complete this and then I will sleep. Not sleep, right? The group by class is used to group rows that have the same values in a specific columns into summary rows. It is typically used with aggregate functions to perform calculations on each group. Okay, where a group by having order by. Okay, these are the aggregate functions, and this is the employee and count star. Okay, okay. Group by department. Okay, sum of salary. Group by department. Okay, 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 okay. That is not too bad, honestly. Elaborate the closure of a set of functional dependencies. A functional dependency is a relationship. Yeah, closure was not told to us people. We can say B is functionally dependent on attribute A written as A functionally dependent on B for every valid value of A. There is exactly one associated value of B. Okay. F plus contains what is closure set? A complete set of all functional dependencies that can be logically derived from using inference rules. Did we get it? Armstrong's axioms, reflectivity. If y is a subset of x, then x is functionally dependent on y. Reflexivity, augmentation, transitivity. All three rules are sound. They only derive value like this. Okay, reflexivity, augmentation, transitivity. Okay, pseudo transitivity. X है वही पता चलेगा और W is x with x you get y. So Why? You get that? Okay, that is pseudo transitivity. Attribute closure. The attribute closure is the set of all attributes with respect to f is functional. Okay, I have done this for actually get. This is a functional dependency. These are functional dependencies, right? Right closure one iteration one. So A can functionally determine B. A is subset of A is at B. And what is this? B is a subset of A star. Okay, this is not functional dependency, right? With A you can get B, so A star contains AB. With B you can get C, so A star contains ABC. With the CD you get E, you have C, but D is missing, so skip it. Iteration 2. Yeah, okay. Okay. A functionality determines ABC. ए से बी पता चलेगा, बी से सी पता चलेगा, लेकिन ई पता चलने के लिए बहुत सीढ़ी चाहिए। डी आपको नहीं है, सो ये क्लोजर गिव्स यू ए बी सी। ओके, ओके, ओके। A alone is not the super key. AD is a super key. Okay, I have read this after like long time and now it is making some sort of sense. What is the normal form in database normalization and what conditions a table must meet to satisfy normalization? Normalization is the process of designing database tables to minimize redundancy and avoid update or insert or delete anomalies. It progresses through normal forms 1, 2, 3, BCN, 4 and first normal form. All values are atomic, invisible, no keys, no sets, no arrays, no repeating groups. Each column has a unique name. Each row is unique, has primary key. Second normal form. There are no partial dependencies. Even non-key attributes must depend on entire primary key, not just part of it. Partial dependencies only occur when primary key is composite. Example of violation: table enrollment, student ID, course ID, student name, grade. Primary key is student ID, course ID. Student name depends only on student ID. It is a partial dependency. Okay, split the table into student ID, student name, student ID, course ID, grade. A table is in 3NF if it is satisfied 2NF. There is no transitive dependency. Every non-key attribute must depend directly on the primary key, and a transitive dependency occurs. Okay, so uh, a functional dependency A to B holds in 3NF if functional dependency A to B holds in 3NF if J is a super key or B is a prime attribute, right? And in BCNF, A should be candidate key and there are no exceptions. You made it okay. This is why 3NF is more lenient. It allows certain dependencies to remain if dependencies a dependent side is a prime attribute, even if determinant is not a candidate key. A functional dependency only allows if A is candidate key. BCNF is checker because it does not care whether B is prime or not. It only checks the determinant side. Okay, that is one rule that I have searched for like in the Stack Overflow, I think, right, for some hours and then finally found it out. Okay, I forgot to write the diary actually. Okay, this is transitive dependency. Converting it to 3 and Dr. Sharma's name changes. Okay, decompose it into two tables. So, what is the transitive dependency? Roll number, department ID, department name, department ID to each OD. Transitive dependency. Roll number to department name is a transitive dependency. So, how do you split the table? So, roll number, name, department ID, roll number, department name, HOD. Yeah, because department ID is required, right? Roll number, department ID. Alright, here this is a transitive dependency. So roll number. Alright, what we did is we get the department name to another table. Yes, and it is dependent on department ID. So department ID will be in both the tables. Okay. Boy Scout normal form is a stronger version. X must be super G of R. Okay, he is making like a lot of analysis of this, and I don't have time for all of this analysis. Fourth normal form in database normalization, and how does it address multivariate dependencies? A multivariate dependency MVD occurs in a relation when one attribute independently determines a set of values of another attribute unrelated to other attribute. Notation A indicates B. A multi determines B. For each value A, a set of B is independent of all other set of values of B is independent of all other attributes in a relation. If when two tuples have the same value of A, we can swap their B values and still get valid tuples. Employee ID hobby. Employee ID independently determines the set of hobbies. Redundancy. Every combination of hobby and phone must be stored for each employee. Insertion anomaly. This causes data redundancy. No non-trivial multivariate dependencies. Then decompose it. Redundancy is eliminated, that is enough. List the acid properties, all or none. A transaction is an atomic unit. It either executes completely, all its operations succeed, or does not execute at all. If any operations were all previously completed operations are rolled back as if they never happened. Prevents partial updates from corrupting the database. Ensures consistency. Okay, begin transaction. I see. Yeah, any rollback consistency data must be always valid. The database must get transferred, like transition from one valid state to another valid state. The constraints are never violated. Example, bank balance can never become negative. Isolations, transactions do not interfere. Each transaction must happen as if like it is the only transaction that is being executed, even if there are other transactions are being executed. Durability. Committed data is permanent. Once a transaction has been committed successfully, its changes are permanently stored in the database. Even if system crashes, power fails, or hardware fails immediately after the commit, guarantees that committed data is never lost. Eliminates the examine the during its execution a transaction passes through several states until it finally commits or aborts. List all possible sequence of states through which a transaction may pass. Explain why each state transition may occur. A transaction is a unit of program execution that accesses and possibly modifies various data items. Active partially committed, failed and aborted. This is the initial state of every transaction. Did he write the diagram? Okay. I need to read this. Yep. This is the initial state of every transaction. A transaction enters the active state as soon as it begins execution. All the operations of the transaction read, write, and compute are being performed. The transaction is currently running. Data modifications may be temporarily stored in buffer, not yet permanently returned to disk. Partially committed. If the transaction executes the last statement successfully, if any error occurs during transaction. Transaction is basically a set of instructions that needs to be treated as a single unit by the transaction manager. Right? And any transaction must follow all the four stated properties: atomicity, consistency, isolation, and durability. Partially committed. Okay. The transaction has executed the final statement successfully. All the operations have been completed, but the changes have not yet been permanently saved. Committed to the database. The DBMS is saved to committed. Committed state has completed on its operations, and the changes have been permanently saved to the database. The DBMS writes a commit record to the log. A transaction enters a file state when it cannot proceed normally due to some error. Aborted. A transaction enters a failed state. The DBMS performs a rollback. It undoes all the changes made by the transaction, restoring the database to its state before the transaction began. This is called terminal or final state. You need to just read the final unit. And serial and serializable schedule. When multiple transactions execute concurrently at the same time in a database, the sequence of operations reads or writes from all transactions together is called a schedule. That EBMS must ensure the concurrent execution produce correct results, the same result as if transactions ran one after the another. Serial schedule. A serial schedule is a schedule in which transactions are executed one after the another, no interleaving. One transaction completes entirely before the next one begins. Right. There are n factorial possible serial schedules always produces, which is only one transaction, two resource allocation and throughput. Serializable schedule. Serial schedule. A serializable schedule is a schedule that is equivalent to the final effect of some serial schedule, even though the operations of different transactions may be interleaved. In other words, even though transactions are running concurrently interleaved, the final result is the same as if they run one after the another in serial order. Operations from multiple transactions are interleaved. The final database state is the same as some serial execution. Concurrency is allowed but correctness is maintained. Conflict serializability. Two operations are said to be conflict if they belong to different transactions and they access the same data type and at least one of them is right, kind of like the critical section problem. A schedule is conflict serializable if it can be transformed into a serial schedule by swapping non-conflicting operations. Precedence graph. You need to check the fifth unit, right? Hash-based indexing, with an example, indexing is a technique used to speed up data retrieval in a database. Instead of scanning every record, full table scan and index helps the database jump directly to the required record. Hash-based indexing is one type of indexing that uses a hash function to map data values directly to their storage locations. A hash function, a hash table is generally maintained by structure of hash index. The storage is divided into B buckets. Each bucket can hold one or more records. A static hashing. The number of buckets is fixed. Dynamic hashing can grow or shrink dynamically as records are inserted. Uses a directory. Okay, 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 okay. Right. I have kind of scanned the entire answer sheet. It is actually good and it took us like 1 hour 4 minutes. And now I think I should be like looking at the syllabus of the fifth unit in more detail because fifth unit is, yeah, fifth unit. We will learn this and then we will learn this as well. That is it, right? Yeah. And I think I will take a break as of now.